For today's video, we have to tackle about the chapter 5, Ethernet summary. So let's start. So it's composed of Ethernet protocol, which is composed of Ethernet frame, Ethernet MAC addresses, the MAC addresses table, switch forwarding method, switch port settings, MAC and IP, ARP issues, Ethernet encapsulation, MAC sublayer, Ethernet evolution, Ethernet frame fields, MAC address and hexadecimal MAC address, and Ethernet identity, frame processing, MAC address representation, unicast MAC addresses, multicast MAC addresses. So for let's start in Ethernet frame, Ethernet encapsulation. Ethernet is most likely widely used local area network technology today. Ethernet operation is the data link layer, then physical layer. This family of networking technologies that are defined in the IEEE 802.2 and 802.3 standards. Ethernet supports data bandwidth of 10, 100, 1000, 10,000, 40,000, and also 100,000 Mbps per second. So MAC sublayer is composed of two: data encapsulation and media access control. Data encapsulation. The data encapsulation process includes frame assembly before transmission and frame disassembly upon reception of the data, informing the frame. The MAC layer adds a header and trailer to the network layer PDU. The data encapsulation provides three primary functions. Number one is frame delimiting, next is addressing, and the last one is error detection. So the next one is Ethernet evolution. Ethernet evolution. Since the creation of Ethernet in 1973, standards have evolved for specific, faster, and more flexible versions of the technology. This ability for Ethernet to improve over time is one of the main reasons it has become so popular. Early versions of Ethernet were relatively slow at 10 Mbps. The latest version of Ethernet operates at 10 gigabits per second and faster. Scroll through the timeline. At the data link layer, frame structure is nearly identical for all speed of Ethernet. So next one is the Ethernet frame fields. The minimum Ethernet frame size is 64 bytes and maximum is 1518 bytes or 1518. This includes all bytes from the destination MAC address field through the frame reject sequence or FCS field. The preamble field is not included, which describes the size of the frame. Any frame less than 64 bytes in length is considered a collision fragment or run frame and is automatically discarded by receiving stations. Frames with more than 1500 bytes of data are considered jumbo or baby giant frames. Next one is the Ethernet MAC addresses, and the first one in this is the MAC address and hexadecimal. An Ethernet MAC address is a 48-bit binary value expressed as 12 hexadecimal digits, or 4 bits per hexadecimal digit. Just as decimal is based in the 10-number system, hexadecimal is base 16 system. The base 16-number system uses the numbers 0 to 9 and letters A to F. So the next one is the MAC address Ethernet identity. In Ethernet, every network device is connected to the same shared media. Ethernet was once predominantly a half-duplex topology using a multi-access but or later Ethernet hubs. This meant that all nodes would receive every frame transmitted to prevent the excessive overhead involved in the processing of data frame. MAC addresses were created to identify the actual source and destination. MAC addressing provides a method for device identification at the lower level of OSI model. Although Ethernet has now transitioned to full duplex NICs and switches, it is possible that the device that is not intended destination will receive an Ethernet frame. So the next one is frame processing. The MAC address is often referred to a burned-in address or BIA because historically this address is burned into ROM, or also known as read-only memory on the NIC, which means that the address is encoded into the ROM chip permanently. So next one is the MAC address representation. On the window host of the ipconfig/all command can be used to identify the MAC address of an Ethernet adapter. Yes, next one is the unicast MAC address. In Ethernet, different MAC addresses are used for layer 2 unicast, broadcast, and multicast communications. The unicast MAC address is the unique address used when a frame is sent from a single transmitting device to a single destination device. The next one is the broadcast MAC address. A broadcast packet contains a destination IP version 4 address that has all ones in a host portion. This numbering in the address means all the hosts on the local network broadcast domain will receive the process the packet. Many network protocols such as DHCP and ARP use broadcast. So the last one is the multicast MAC address. The multicast addresses allow a source device to send a packet of a group of devices that belong to a multicast group as assigned a multicast group address. The range of IP version for multicast address in 224.0.0.0 to 239.255.255.255. The range of IP version 6 multicast addresses begin at FF00.8 because multicast addresses represent a group of addresses, sometimes called a host group. They can only be used in the destination of a packet. The source will always be a unicast address. So the next one is the MAC address table, which is composed of switch fundamentals, learning MAC address, and filtering frames. So the switch fundamentals, as we all know, a layer 2 Ethernet switch uses MAC addresses to make forwarding decision. It is completely unaware of a protocol being carried in the data portion of the frame, such as an IP version 4 packet. The switch makes its forwarding decisions based only on the lower 2 Ethernet MAC addresses. Unlike legacy Ethernet hubs that repair bits out of all ports except the incoming ports, an Ethernet switch consults a MAC address table to make a forwarding decision to each frame. So the next one is the learning MAC address. The switch dynamically builds the MAC address table by examining the source MAC address of the frames received on a port. The switch forward frames by searching for a match between the destination MAC address in the frame and an entry in the MAC address table. Next one is the filtering frames. As switch receives frames from different devices, it is able to populate its MAC address table by examining the source MAC address of every frame. When the switch MAC addresses table contains the destination MAC address, it is able to filter the frame and forward out a single port. Next one is the switch forwarding methods. Frame forwarding methods on Cisco switches. Switches use one of the following forwarding methods for switching data between network ports. One is store and forward switching, and the last one is the cut-through switching. In store and forward switching, when the switch receives the frame, it stores the data in buffers until the complete frame has been received. During the storage process, the switch analyzes the frame for information about its destination. In this process, the switch also performs an error check using cyclic redundancy check, or CRC, trailer portion of the Ethernet frame. CRC uses a mathematical formula based on a number of bits ones in the frame to determine whether the received frame has an error. So next one is the cut-through switching. In cut-through switching, the switch acts upon the data as soon as it is received. Even if it is transmission, it is not complete. The switch buffers just enough of the frame to read the destination MAC address so that it can determine the switch to which port to forward the data. The destination MAC address is located the first 6 bytes of the frame following the preamble. The switch looks up the destination MAC address in which the switch table determines the outgoing interface port. The forward the frame onto the destination through the designated switch port. The switch does not perform any error checking on the frame. The last one is the memory buffering on switches. An Ethernet switch may use the buffering technique to store a frames before forwarding them. Buffering may also be used when the destination port is busy due to congestion, and the switch stores the frame until it can be transmitted. So let's the ARP issues. ARP broadcast and ARP spoofing. ARP broadcast. The broadcast frame an ARP request is received and processed by every device on a local network on a typical business network. This broadcast would probably have minimal impact on the network performance. However, if a large number of devices were to be powered up and all start accessing network services at the same time, there could be some reduction in performance for a short period of time. So the next one is ARP spoofing. In some cases, the use of ARP can lead to a potential security risk known as ARP spoofing or ARP poisoning. This is a technique used by an attacker to reply to an ARP request for an IP version 4 address belonging to another device, such as the default gateway as shown. The attacker sends an ARP reply on its own MAC address. The receiver of the ARP reply will add the wrong MAC address to its ARP table and will send packets to the attacker. So that's all for chapter 5 Ethernet summary. Thank you for listening and stand by for the chapter 6 summary. Thank you.